So I did numbers 1, 4, and 7 because those are totally different answers. 1 through 3 is you're finding the grams of the substance. 4 through 6, you're finding the molarity, which the formula for that is right in red. It's number of moles of solute divided by the mass of solvent in kg. The solvent in this case is, it looks like it's going to be, it would look like it would be water. The solute is something that you're going to put in. So the solvent is basically what you have in a container, and the solute is what you're going to put into the container. So just remember, the solvent is already in the container. The solute is going to be dissolved in the container. You can tell this by, in the question it says that MgCl, magnesium chloride, dichloride, is going to be dissolved in it. So that is going to be the solute in this case. Number 7, that you are finding the molar concentration, or in easier terms, molarity, not molality, molarity. If you get a conversion sheet, I don't know if you get it, but molality is the lowercase m, and the molarity is the bigger case m. Okay, so know that, and I wrote that here. This has a big M. This has a little m. So lowercase molality, uppercase molarity. And I believe you do get it. And basically, when you look at that formula sheet, you're able to determine what you need to do, because it basically just gives you what you need to find. Like if it says moles of solute, you gotta take the grams divided by the molar mass. That's how you find the moles, and you can figure it out. Okay, so first question is, you have 2 liters of 6 molar HCl. Okay, when you think of the 6 molar, you can also convert that and just say it's going to be 6 moles of a substance. Same thing. When you're doing the conversion, it's the same thing. 6 molar HCl, which is the concentration, which is actually the molarity, the big uppercase M, you see it? You can just convert that to 6 moles when you're converting. So we have what we're starting off with, the 2 liters, which is right here. You're going to take that and you're going to multiply it by 6 moles. You cross out. You don't necessarily have to cross out, but when you're doing the conversion, it's easy to see how to do everything if you have it organized. So you have the liters, you cross those out, because you're going to end up with grams. So you have to make sure what you're finding, which is grams, is the last thing on the list, because you're not going to cross that out. Okay, so you multiply that by the 6 moles that we have. The given, we are also given that, and you cross that out with the 1 mole. And then you multiply that by the molar mass. So this is the molar mass of HCl. And you get 437.4 grams of HCl. Pretty sure that's correct, but if my rounding's off, I don't know. Okay, so the next thing that we're going over, let me pull it up. Okay, so number 4, it says calculate the molality when 75.0 grams of magnesium, let me think about it, magnesium chloride is dissolved in 500.0 grams of solvent. So I just wrote that. The orange is just what the question is. So I have obviously the conversion here for molality, if you want to write that down, but I'm sure it's on the formula sheet that you probably have. So the first thing that we have to do, as you can see here, oh, I guess I did this one first. So let me write it down. So this is in green, and this is in blue. No, I mixed that up. Sorry. Whoops. This is in blue. and this is in green. Cover that up so you can't tell. Okay, so that's what you need to follow. So I did the mass of the solvent first. Doesn't matter what order you do it in because you're just going to put whatever you get at the bottom. So when you convert 500 grams to kilograms, you're moving the decimal place 3 spaces to the left, or you can divide it by 1,000. 500 divided by 1,000 is 0.500 kJ. Let me make sure that's right. Yeah. You don't even have to have the extra zeros if you don't want to. I just had it. So that's all you do. When you're dividing by 1,000 to a number, you're just moving it 3 decimal places because there's 3 zeros. So if you don't even want to do that, that's fine. Okay, then I have to find the number of moles of solute, which you're going to take the 75 grams because the one at the bottom, the 500 grams, it says 500 grams of solvent. So you had to use the solvent conversion, which is this one, for the solvent. Now, this one, the solute is what you're putting in, which is the MgCl2 because it says you're dissolving it. So that's what's being put in. So you take the mass of the given that you're given, which is 75.0 grams, right here. Then you take the molar mass, which is 95.2 or around 95.2, and you get around 0.78 moles. Now, we have both of our answers, but we're not done yet. We have to put these answers into the molality conversion. So you're going to take 0.78 moles, because it says moles of solute, divided by the mass in kg, which is right here, this little division, and you're going to get around 1.56 moles kg to the -1. Why do we put the -1? Because you divided it, and that's just what we do. Okay, so the third problem that I did was the last problem, because that's the only one on that page that has molarity on it, which is the big M, the capital M. Let me read the problem. Okay, so we have determined the molar concentration, which is capital M, which is molarity in similar terms, of a solution in which 320 grams of glucose, C6H12O6, are dissolved in 4,000 grams of water. So we have the conversion here, which is the moles of solute, which is going to be in red. That's my conversion of the moles of solute. And we have to find the volume in liters of the solution. So I have the moles of solute in red, the liters in blue, and the orange is my 2 numbers that I took from that and put it into the conversion. So you have to take what you're given, which you're given 320 grams of the solute, which is the glucose, and it even says that it is going to be dissolved, which means that it's the solute. So you're going to take that. So you're going to take that conversion. So it's going to be 320, which you're given, divided that by the molar mass. If you want to do it just in simpler terms, you can do that, but your teacher might make you, lay it out like this. And you get 1.77 moles. The next thing you have to do is the 400 grams of water, which is the solution that is going to be made. And you are basically just multiplying that by 0.001 liters, because that is how many liters are in 1 gram of solution, because you have to cross out these grams and you end up with liters, which is what you have to end up with to get to this point. Okay, and then you got your, now we're going to go back up to the top where it says the molarity solution. So you're going to have moles of solute divided by the liters. So moles of solute divided by your liters, and you get 0.44 molarity.